Hey guys, it's Miss Johnson and I'm here to bring you our notes for Lesson 6. Today we're doing Unit 1, Note 6, which is box and whisker plots. We're going to talk about how to make a box and whisker plot, how to read a box and whisker plot, and all things box and whisker plots today. So if you haven't already done so, go ahead and find your calculator. You're probably going to want that today. And get some paper out to take some notes with, or if you're taking them on your iPad, find something to write with, whatever you need. All right, a box and whisker plot is yet another graphical display that we have for quantitative data. We take our data and we split it into 4 equal groups. We're splitting our data up into 4 equal groups, which means there's 25% of the data in each group. We use a number line to organize that data and to show where it falls within the range of the data, but we're splitting the data up into 4 equal groups. So just to give you a general picture of what a box and whisker plot looks like, if I was going to make a box and whisker plot, I don't have any data here. I'm just drawing a rough sketch of an example of one. So this is not real. This is made up of fake data. So I would have my number line down here going from whatever to whatever. My box and whisker plot, there's a box in the middle that has a line down the middle of it somewhere, or a line in it somewhere, and then there's a whisker that comes to the outside. So that's what a box and whisker plot kind of vaguely looks like. And then there's these 5 points that we will be finding on the box and whisker plot. I'm going to talk about those on the next slide. So you've got a number line, you've got your box in the middle, you got your box here, and you've got your whiskers that come out to the outside. So to make a box and whisker plot, you need to have a 5-number summary. There's obviously 5 numbers in this 5-number summary, and a few of them are ones that you're very familiar with. The last couple we'll have to talk about, but the minimum obviously is the lowest number. The maximum is the highest number. So those two are pretty obvious. The median, we spent a lot of time talking about the other day. Median is the middle point of the data set. You have to put the data in order first, okay? Then the lower quartile, okay? So this is the next one that you would find. The lower quartile is the median of the bottom half. So it's kind of like if you take a piece of paper and you fold it into fourths. If you want to take a piece of paper and fold it into fourths, you're going to fold it in half first, then you're going to fold those 2 halves in half again. And that's what happens with your data. We take our data and we cut it in half first with the median, and then we cut each half in half again to get the quarters. So the lower quartile is when you cut the bottom half of the data in half, and the upper quartile is when you cut the top half of the data in half. So it's the median of the bottom half and the median of the top half. The lower quartile is also called Q1 because it's the first quartile of the whole data set. The median is technically also called Q2 because it would be the second quartile of the whole data set. And the upper quartile is technically called Q3 because it marks the third quartile of the whole data set. So this is like your first 25%, this is your 50% marker, and this is your 75% marker, okay? So the first 25% of the data is under the lower quartile, the first 50% of the data is under the median, the first 75% of the data is under the upper quartile, and then you really could call the maximum Q4 because 100% of the data is underneath the maximum, okay? So anyway, this is our 5-number summary: minimum, maximum, median, then lower quartile and upper quartile. And that's typically the order you'll find them in. You'll find them in the max first, then you'll look for the median, then you'll split those 2 halves in half again. All right, limits. So sometimes we have data. We've talked about how data is not perfect. It's not perfect, it's raw, it's messy. Sometimes we have data in our data sets that are outliers. They're very far away from the general pattern. There could be a lot of reasons for outliers. You could have just a really unique, data entry, be it a person or whatever you're recording. There could be something about it that's just unique. There could be an error. Somebody could have marked the data inaccurately, That is possible when you're recording data. It's human error. People make mistakes all the time. So there's a lot of reasons that outliers could exist in data. Now, the thing about a box and whisker plot is if you leave those outliers as part of the plot, it's going to make a very big difference in how the plot looks. So what we do is we calculate limits. When we calculate the limits of the data, we determine where our outliers are, and those outliers become removed from the general part of the box and whisker plot. We still graph them, but we don't put them in with the box and whiskers. They're graphed as a point outside. So it says the limits are of a set of data are calculated to determine if there are any outliers. Find the limits after you calculate the 5-number summary, but you got to do it before you graph because it's going to change the way your graph looks. If there is an outlier, you change the way the graph looks. If the outlier is found, it does not change your minimum or maximum, it just changes how you graph. So the graph will look different depending on what your outliers are, but they're still going to be on there. They just are marked different. All right, so determining the outliers. This is a tricky one that's not really going to make a whole lot of sense until we do it a couple times, but I'll talk you through the steps so that you can see what they are. So basically, we need to determine the outliers based on the interquartile range. The interquartile range is the middle 50% of the data. You take Q3 minus Q1. This is also the range of the box. You'll see what that looks like when we actually create one of these things. Once we find the IQR, you'll see this recorded as IQR quite often. That's how it's labeled. Once you record the IQR, you're going to multiply that IQR by 1.5. It's literally called the 1.5 IQR. Then you subtract it from Q1. So you're basically going from the box out. So subtract it from Q1, because this is where your Q1 will be on the box. This is where your Q3 will be on the box. And you add it to Q3. Those become your limits. If at minimum or maximum or any point, because sometimes there's more than one, if any data falls outside of those two values, then they're considered outliers. We still graph them on the number line, but they're graphed as a point outside of the whiskers. They're not part of the box and whisker plot anymore. All right. So let's take a look at our data set here and just do an example of this. I have a set of data, and it says create a box and whisker plot for the given data, list the IQR and the 1.5 IQR. So the first thing that I'm going to do is check that my data is in order. My data has to be in order. I didn't mean to change that one. I meant to change the white one, but that's okay. So check that your data is in order. 6, 10, 11, 15, 20, 21, 21, 22, 23, 28, 29, and 50. It appears that my data is in order. It's good to know the N. I like to know the N. That's helpful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. My N is 13. That means I'm going to have a true middle, which is kind of nice. You'll have a true median. So the first things that you look for, the min and the max. There's my minimum. There's my maximum. So 6 and 50. Then I'm going to look for the median next. So the median, if I have 13 data points, the median is going to be the 7th one. So I'd have 1, 2, 3, 4, 5, 6, 7. And you can just check. There should be 6 data points on either side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Or you can do the good old-fashioned cross off from the ends. 2, 3, 4, 5, 6. Either way you slice it, really, you'll get to that median of 21. Okay. Now let's talk about Q1 and Q3. I'm going to erase this a little bit so that it's a little bit easier to see. Okay, so this was my minimum. Here's my median. Okay, that's the median. If I want to find Q1, I need to look at the lower half of the data. Now here's where life gets a little bit tricky with the Q1. You don't include the median there. The median is the true center. It's not part of the lower half and it's not part of the upper half because it's truly in the middle. it's not in either section. You can't count it twice, so you can't put it in both sections, but it's truly in the middle, so it's not the bottom half and it's not the lower half, or the upper half. So if I'm finding Q1, that means that I need to look from the point that's right below the median to the bottom, okay? So I'm doing the median of this little group that I have in my purple brackets there. So 6 and 21, 10 and 20, it's between the 11 and the 15. So then I would take 11 plus 15 divided by 2, because it's somewhere in here. That's 26 over 2, which is 13. So my Q1 is 13. And again, I'm not going to include the median in that because the median is truly in the middle. It's not part of the lower half. Same way, it's not part of the upper half either. So I need to not count it when I'm looking at the upper half of the data. I'm outside of that median. So I start at the other 21 that's right above it and go up to the 50. And if I go through those, I'm between the 23 and the 28. 23 plus 28 over 2. And that's just simply because I have an even number of data points that I'm looking at there. So 23 plus 28, that is 51 over 2, which is 25 and a half. I did that in my head. If you want to whip out your calculator and work on that, that's just fine. So 25 and a half. Okay. So there's my 5-number summary. Now, before I graph my actual box and whisker plot, because the thing about box and whisker plots is you do a lot of prep work before you can even get to the point that you're ready to graph them. So that was just my 5-number summary. Now I have to do the limits. So the next thing I'm going to do is do the IQR. Let me get a little bit better green here. So my IQR is going to be the Q3 minus Q1. So I have 25.5 minus 13. 25.5, I think that's 12 and a half, but my brain, it's good to check. 12 and a half. So that's my IQR. Then I want to go ahead and take that and multiply it by 1.5 times 1.5. And I get 18.75. All right, so that is like the acceptable distance. What this number is right here, that's the acceptable distance that I'm allowed to go outside of the Q1 and Q3. That's what makes it reasonable. It's reasonable for me to be 18.75 units away from Q1 and Q3 and still be in the data set. If there are things that are more than 18.75 units away from Q1 and Q3, then they're considered outliers because they're too far away. They're beyond the reasonable limit. Then something must have happened where that distance was too far away. Either something was recorded in error or whatever. So the way we find that now, the lower limit and upper limit, that's what LL and UL is, lower limit and upper limit. The way we find that is to take the lower quartile and subtract that limit. And you're going to get a negative number here, and that's okay. 13 minus 18.75 is negative 5.75. Okay, so that's my lower limit. Then the upper limit is I have to go outside of Q3. So take 25.5 and go above it. 18.75. 25.5 plus 18.75 is 44.25. Okay. So I've got my lower limit and my upper limit. Now let's take a look at those limits compared to my data set. So the thing that happens here is the negative 5.75 is way down here, okay? I don't need to worry about any of my data being outside of that. My lowest data value is 6. So I'm well within my range on the lower limit side. However, on the upper limit side, my upper limit is 44.75. Now, I want you to remember something. 44.75 is not 25, sorry. It's 44.25. 44.25 is not data. All that is marking a reasonable boundary for our data to fall within. It's not its own data point. It's not a new point that we're going to graph. It's simply a marker. It's a boundary line. What happens with this boundary line is I've got this 50. This 50 is on the outside. That's an outlier. this 50 now becomes an outlier. Okay, so that's going to change the way that we graph it. Instead of my whisker ending at 50, my whisker now has to end at the 29 because that's my next my next lower data point. I have to graph the 50 as a point on the number line, and the whisker comes down to the 29 because 29 is within my reasonable limit. Remember, 44.25 is the reasonable limit, but 50 is outside of that, so it's an outlier. Okay, I didn't leave you a whole lot of space on the bottom, and I apologize for that, but I'm going to try and go ahead and actually squeeze my box and whisker plot in here. So draw yourself a number line, okay? On your number line, because now we're actually making the plot. All of the stuff we've done so far is just prep work. We haven't even made the display yet. So draw yourself a number line. On the number line, I need to go from 6 up to 50. So I'm going to start at 5, and maybe I'll count by tens. Or I could start at 0 and count by tens. If I do that, 0, 10, 20, 30, 40, 50. I didn't space those out super well, but that's okay. 20, 30, 40. And I'm sorry, I'm writing so small on the bottom of the screen. Hopefully you can read it. Okay, so now let's plot in our points. So my minimum is 6. My lower quartile is 13, right about there. My median is 21. My Q3 is 25.5. And now that last whisker is going to be 29. And then up here at 50, you've got an outlier. Okay, so there's my 5 number summaries. There's my outlier. These middle 3 lines are your box, and then the out 2 lines are your whiskers. And there you have it. There's your box and whisker. So what happens here is now I know that 25% of the data, where did my blue go? 25% of the data is right there. 25% of the data is right there. 25% of the data is right there, and 25% of the data is right there. That is the point of the box and whisker plot. You're splitting your data into fourths. You threw out the outlier because the outlier is going to dramatically affect your box and whisker plot, so we don't count it. It was outside of those reasonable limits that we found, so we don't count it inside the box and whisker plot. But you have your box and whisker plot split into 4 equal sections. Now, the thing that also kind of makes people a little confused about this sometimes is the box and whisker plot is split into 4 equal pieces of data. It's not 4 evenly spaced things. It has the same number of data points, but they're not equally spaced apart. So that's why this side of the box is a lot bigger than that side of the box, because this data is just more spaced apart. That piece of data right there is more spaced apart. This data is closer together. All right, we're going to do this, and then we'll be good. So let's create the box and whisker plot, given the IQR and the 1.5 IQR, and we're going to list the 5 number summary and all that jazz. So starting off at the top, I have my data listed in order again. I know that I'm good there. Let's count our N. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 points. So I'm going to have a median between 2, and that's okay. Minimum 66, maximum 99. Now let's do our median. So if I cross and cross and cross and cross, it's between 84 and 90. So I'd have 84 plus 90 divided by 2, and that gives me 87. Okay, so now we talked last time. I'm going to erase those little notes there because we're done with the median. Come on. There we go. We talked in the last example about how, so my median is right here at 87. My median is the true middle. It's not, this isn't even data. We don't have this as a data point. It's just the average of the 2 that are in the middle. So we don't include the median. We include the data that's below it. Okay, so when I find the median of the lower half, I'm looking at this 80 right here. Then I find the median of the upper half, and I'm looking at 91. Okay. All right, so there's my 5-number summary. Now I'm going to find the IQR. IQR is Q3 minus Q1, so 91 minus 80, which is 11. 1.5 IQR is 1.5 times 11, which is like 16 something. 11 times 1.5. Yep, 16 and a half. Perfect. Oops, 16 and a half, sorry. So that's the distance I'm allowed to go outside of Q1 and Q3. So now let's find our limits. Lower limit, Q1 is 80. Subtract the 16.5, because that's how far away you're allowed to go, and data can still be reasonable. So 80 minus 16.5 is 63 and a half. And then the upper limit, I take the Q3, and do 91 plus 16.5, because again, that's about how far away I'm allowed to go. And that's going to give me 107.5. A lot of times I do all that math in my head, but I second guess myself, so then I type it in my calculator. Anyways. All right, so there's my 5-number summary. There's my data. Oh, and I jumped to my number line quickly because in my head, I didn't say this out loud, but in my head, I recognize that 63 and 107 are outside of my data. So there are no outliers here. There's no outliers in this question, okay? Because 66 is above the 63, so I'm inside the range, and 99 is below the 107, so I'm inside the range. So all I have to do here is graph my 5 numbers. So I need to go from 66 to 99. I'm going to go to 65, and I'm going to count by 5s. 70, 75, 80, 85, 90, 95, 100. And again, I didn't space my notes super well, but that's okay. 70, there's 80, there's 90. As long as they're marked, it's not a drawing test. You don't have to have perfect penmanship or drawing or spatial relationships. As long as you mark your data, then you're good. So let's put our points in. I have the minimum at 66. I have the lower quartile at 80. I have the median at 87. I have the upper quartile at 91. And I have the maximum at 99. So I just straight up graphed those 5 points right there. The middle 3 become the box, and the outsides are the whiskers. There you have it. So again, each of these sections is 25% of the data. Good boy. And you can tell, like, your lower data is spread out more than this piece right here, and more than that piece right there. And this part of the box is spread out more than that part of the box. That's just the simple spread of the data. This is still 25% of the data points. This is still 25% of the data points, okay? All right, we have one more box and whisker plot. I lied. I thought we were on the last one, but this is actually our last one. So I'll do this one. I'll try to go through it rather quickly, and then you guys will be off and running, but this will just give you another example to look at. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N is 12. I'm going to, I wrote 10. I'm going to have a median that's between 2 again. So N is 12. My data is in order, so I'm good to go there. I have 30 for a minimum. I have 75 for a maximum. And then let's count to the middle here. It's going to be between the 6th and the 7th. So 1, 2, 3, 4, 5, 6, and 7. Your median is right here. That's 54 plus 56 divided by 2, which is going to be 55. So there's my median. So then let's do the quartiles. Lower quartile is the middle of the bottom half, median of the bottom half. So if I look for the median of the bottom half, I'm at 30, 54, 32, 52, 50, and 51. It's between those two. So my median of that is 50.5. And then median of the upper half, I have 56, 75, 56, 60, 57, 58, so 57 and a half. All right, let's take a look at our IQR. My IQR is going to be 7. I can see it already because those two subtracted. 57.5 minus 50.5 is 7. So then 1.5 times 7 gives me the IQR. And I think that's 10.5, but you know, let's just, yeah, check, because it's good not to make a mistake. All right, so 10.5 is the limit that I'm allowed to go outside of those quartiles. So 50, my lower limit is 50.5 minus 10.5. And 50.5 minus 10.5 gives me 40. Ooh, that's supposed to be an equal sign. Check out that lower limit. We got some data underneath. So upper limit, I have 57.5 plus 10.5. 57.5 plus 10.5, and I get 68. I have some outliers here. Holy buckets. I got a handful of them. So my outliers here, 40, there's the 40, which means that's an outlier and that's an outlier. So that's going to be a point and that's going to be a point, and this is going to be your new end of the whisker. 68 is right here, so that means this is also an outlier, and this is going to be your new end of the whisker. So check out how this is going to change our display. I'm glad we did this example. So that you guys could see it. So here's our actual box and whisker plot now. Okay. I still need to go from 30 to 75. That still has to be a thing. So 30, 40, 50, 60. I need to space those out better. Let me space those out better. 40, 50, 60, 70. So 75 will be right about there. Okay. So I'm going from 30 to 75. My 30 and 32, I should probably mark those in. 30, 40, 50, 60, 70. My 30 and 32 are outliers, so I'm going to plug those in as outliers. The 75 is also an outlier. I'm going to plug that in as an outlier. That makes my whisker come to the 50. So now my new whisker is all the way up here at 50. The lower quartile is 50.5, right next to it. That's a really teeny tiny short whisker. My median is 55. The upper quartile is 57.5. Look at how close together this box and whisker plot is. And then now my new upper whisker is 60. Okay, look at what happened to our data once we threw out the outliers. Once we took out the outliers, all of this middle piece of our data was so close together, and these things were so far apart that it made our box and whisker plot so small in the middle, so close together. The range of the box and whisker plot is really small. It only goes from 50 up to 60. It's all within 10 points. And then those outliers are outside by themselves. So that's how this can make a really big difference. Because if you think about it, if we wouldn't have calculated the outliers, our whisker would have been all the way down there, which is weird. It's a lot different looking plot when you think of it that way. But when we take those outliers out, it shrinks up that data and shows you, or shrinks up that plot and shows you how close they actually were to each other. All right, so that's going to take us to the end of the box and whisker plots lesson for today. Thanks for listening, and I will catch you guys next time.